All right, guys, let's take a look at a few homework problems from 10.1. So we're moving on into the area section here, and we talked about two formulas here in 10.1. The first one we discussed was the formula for area of a parallelogram, and that's what it is that we're dealing with right now. Now, one of the things that I want you guys to get used to is the idea of doing a three-step process for every one of these problems that we're going to be doing here, really in Chapter 10, but most of the rest of the year through 11 and 12. Step number one is always to write down the formula. So since we're dealing with a parallelogram here and we're trying to find the area, I'm going to use the formula for area of a parallelogram, which is simply base times height. Step two is to always fill in what we know. So we're trying to find our area now, and we need to know both the base and the height of that parallelogram. Now, the important idea right here, everybody, and we talked about this in our notes if you guys watch those, and this is going to be true for everything we're going to do in Chapter 10 and 11, it's this important idea right here, that the base and the height in any figure must be perpendicular. Okay, base and height have to be perpendicular to each other. They have to form a right angle. Now, when we talk about base, almost everybody likes to think about base being located on the bottom of a figure. And in a lot of cases, I'd even say the majority of cases, that ends up working just fine. So the base of this parallelogram would go from here to here, and it looks like it's going to have a length of 6. So let's run with that for now. There's no reason to think that's not going to work. So our base looks like it's going to be 6 meters. Now the height then is the measurement of the side that would run perpendicular to that base. Now in this example, we were not given the length of this side right over here, but even if we were, let me just make up something and say that that was 5 meters right here. 5 meters would not be the height of this parallelogram because the sides of 5 and 6 right here are not perpendicular to each other. So that 5, even if that's what it was, is not our height. Our height would actually be measured here outside of the parallelogram because this piece is perpendicular to it. So that 4.6 meter auxiliary line, auxiliary meaning it's not actually part of the parallelogram, but outside it, that's actually your height. So the 4.6 meter measurement goes right here for height. So that was step 2, fill in what you know. And step 3, let's go ahead and multiply everything out here, guys. So a 6 multiplied by a 4.6 is going to get us 27.6. We are multiplying, let's talk about units for a second, meters multiplied by meters. And when you multiply meters times meters, that's when you end up with this unit right here, which almost everybody says wrong, and most of your teachers have allowed you to do this for years, but we got to fix it. Even though we write m with a 2 after it, and it looks like m squared, we don't write this as meters squared. We say it as square meters. Okay, so 27.6 square meters is the area of that parallelogram. Okay, let's look at a problem like number 7 where we flip things around a little bit. Now in this problem, they've already told you the area of the parallelogram, and we're supposed to come up with a missing measurement right over here, which again, I don't like their question marks, so I'm going to go ahead and put an X right there, and we're going to try to figure that out. Part of the reason that I ask you guys to do this 3-step process, even though certainly on the last one it wasn't that difficult, is because this process helps you when all of a sudden now the problem flips around a little bit and it's not exactly like one that we dealt with before. So step 1 is the same. Write down the formula. We're talking about a parallelogram. We're looking at its area, so we write the formula for area of a parallelogram, which is still base times height. Step 2 is the same. Fill in what you know, except this time we were given the area of the figure. So the 6 goes over here on the left, right underneath the A, because we know that our area is 6. The base of this parallelogram, again, we'd like to think of it on the bottom right here, and that side that I just highlighted has a length of 3. And the height of that figure is what's measured perpendicular to that over here on the side. That's the unknown, so that's going to be our X. And then step 3, solve or simplify this equation. Well, here we're trying to solve for x, which is currently being multiplied by 3, so we're going to simply divide by 3 on both sides of this equation, and that's going to get us our solution now that x is equal to 2. If we were talking about units for just a second, the area that we wrote down, 6, was square meters. But the 3 that we wrote right here, if you look at it, guys, was just regular meters. So what we actually did right here is we divided square meters by meters. And just like a variable that you would have dealt with in Algebra 1 last year, m squared divided by m would just be m. Here, square meters divided by linear meters is just linear meters again. So the missing side in this one is going to be 2 meters, and that's the height of that parallelogram. Okay, let's move on to triangles right now. And again, we're supposed to find the area here. So to do this one, step number 1, we now need to transition to the formula for area of a triangle, which is always going to be half the formula we just used for area of a parallelogram. So this is going to be 1/2 times your base times your height. But once again, we have to remember that base and height have to be perpendicular, and that becomes important here. Step 2, fill in what you know. We do not know the area of the triangle. In fact, I can see right here the directions are telling me to find the area, so I'm not supposed to know. So the area of the triangle is going to be 1/2 times, and right here, everybody, this is a great example of why you have to think about the perpendicularity of base and height. As I said earlier, we all like to think about the base being located on the bottom of the figure, and this absolutely could be the base. But to do that, this right here, I'd have to draw a little dotted line in right there. That, perpendicular to that base, would have to be your height. Well, our problem with setting it up that way is that we don't know the length of this base down here on the bottom, nor do we know the length of this height. So you could set it up that way, but really you have to use the information that's presented to you. The only 2 side lengths we know are this long side over here on the right has a length of 12 inches, and then sure enough, this altitude drawn right over here is perpendicular to that 12-inch side. So that means that this 12 here, if you think about flipping this sideways, this 12 is going to be your base, and that 6.6-inch side is going to be your height because they are perpendicular to one another. So we're going to put 12 inches here for base, and height perpendicular to it is 6.6 inches. Okay, and this is a pretty easy one because the variable we're looking for, area, is already isolated. All we need to do now is grab our calculator and type in that entire right side. For a 1/2, you can use the fraction key. You could do 1 divided by 2, or as I think everybody knows, 1/2 is 0.5 as a decimal exactly, and that's probably the easiest way to put it in your calculator. So I'm typing in 0.5 times 12 times 6.6, and that's going to get us an area here of 39.6. And just like we talked about before, linear inches multiplied by linear inches is going to get you not inches squared, everybody, but square inches. So 39.6 square inches is our area in problem number 9. Now, number 12, I wasn't going to do this problem, and then I thought, this one might be a little bit interesting. I did give you some where I had the program there start giving you extra information. So that's kind of a little test right here to find out if you really know what's going on. So step number 1 is always write out your formula. This is a triangle. We're trying to find area. So area of a triangle is equal to a 1/2 times your base and times your height. Step 2, let's fill in what we know. Again, the directions say find the area, so we don't know that yet. That's the unknown. Area, then, is 1/2 times, and here's where the plot thickens just a little bit, because in this problem, we've been given the length of all 3 sides in the triangle, 5 feet, 10 feet, 11 feet, and we've been given the length of an altitude, that red segment in the middle that's 4.5 feet. So how are we supposed to know which ones are the base and the height? Well, I worry that a lot of you guys might get the right answer to this question, but for the wrong reason. The base here is 11, but not because the 11 is located on the bottom. The key to this whole problem is the right angle right here. That means that this side here on the bottom and this altitude right here are the only 2 sides in this figure that are perpendicular to each other. So yeah, 11 feet is going to be your base, and the side perpendicular to it, which is 4.5 feet, that's going to be your height. But let's be clear, those are the base and the height because they are perpendicular to each other. not because 11 is on the bottom. That's irrelevant. Okay, and step 3, let's just clean up this right-hand side, everybody. So I'm going to type into my calculator 0.5 times 11 times 4.5. And that's going to get us the correct answer here of 24.75. And linear feet times linear feet get us an area of square feet. Okay, so you got to be careful with some problems like that. And then I wanted to do one more with you from the end. This is actually the very last problem, I think, on the worksheet, where we're supposed to find a missing measurement. So here we go. We are dealing with a triangle. They gave us the area, so that tells me that we need the formula here for area of a triangle, third time in a row now, which is again 1/2 times base times height. Guys, another good reason to write out your formulas as much as you can. That's the fastest way to be able to memorize them. To write them, to say the words out loud as you're doing it, that's the best way to get all that ironed out and memorized quickly. Okay, step 2, fill in what you know. In this problem, they gave you the area here. So underneath A, our area is 44.6, and that's square miles. I'm going to leave the units out for now. That equals 1/2. And once again now, we need to figure out what's the base and what's the height. And the key to this, everybody, we've got this 11.3 over on the left. We have this question mark that I always want to call x, and then we've got this 8.1 here in the middle. We need our base and our height to be perpendicular to each other. And out of those three, the right angle is right over here. That tells me, everybody, that this side over here is actually going to be our base. So I'm going to put an x right there in the place for base. And the height always has to be measured perpendicular to that base. So that auxiliary line of 8.1 miles does make a right angle with what we've chosen to be our base. So 8.1 can be used for our height. Okay. So that's filling everything in step 2, and now step 3, let's work on solving. Well, this is going to be a 2-step process, I think. There's a little bit of simplification that can be done over here on the right with multiplying the 1/2 and the 8.1. So the left side I'm going to leave alone here and just let it tag along for the ride. In my calculator, I'm going to multiply 0.5 times 8.1, and that is going to give us a 4.05. And the x is still there with it. And now, find your variable, ask what's being done to it. It's being multiplied by 4.5. And what will undo that multiplication? This is division. So we're going to divide both sides here by 4.05. Those ones are going to cancel. And that's going to leave us with x equals, and I'm going to type 44.6 divided by 4.05, and that's going to get us a messy answer right here of 11.01, wow, 11.0123456, and then an 8. That's kind of cool. Anyway, but the directions did say to round your answer to the nearest tenth. So that is going to be 11.0. Remember, guys, when rounding to the nearest tenth, even if that tenths place is a 0, you have to include it. You don't just write it as 11. And what we did there, everybody, was we took square miles divided by linear miles, and that gets us just plain old miles. So, wow, we're talking about a pretty big triangle here. All right, guys, that is 5 of the 16 problems on the 10.1 homework. Let's give the rest a try and see how you do. Please post if you guys have any questions, and I'll work out those and post that as well.